Hi, today we're looking at angle properties and calculations. Here we have a quarter turn. There are 90 degrees in a quarter turn. Look at the little red box. That shows that this is a right angle and there are 90 degrees in a right angle. Now do look for the little box in the corners of angle drawings because sometimes they only give you that little square and they don't give you the number value to go with it. So you're supposed to recognise when you see this little square that it's telling you it's 90 degrees. Now we have a half turn. There must be 2 quarter turns in a half turn. So there are 180 degrees in a half turn. This is sometimes called a straight line angle. And we've got 3 quarter turns. 3 quarters are 3 lots of 90, 270 degrees. Now note, we're talking about this bit. This is the bit that's labelled round the outside here, not this bit in the middle. Okay, this is the bit that measures 270 degrees. And a full turn, if I turned all the way round, back to the beginning again, I would turn through 360 degrees. Okay, let's try calculating some missing angles with that knowledge. Here we have a straight line, and that's a half turn, and we know it measures 180 degrees. So if I cut my 180 degrees into 2 pieces, one of which is labelled over here as 120 degrees, and one which I need to calculate. Okay, no, it's calculate the missing angle. You're not supposed to measure it with a protractor because these drawings aren't done to scale. You're supposed to use some sums to work it out. So let's use the knowledge that a whole straight line is 180 degrees and we've got 120 of those already. Therefore our missing angle must be the 180 degrees we need, subtract the 120 we already have. So our missing angle is 60 degrees. Okay, now we've got a quarter turn here. Note it's got the little box in the corner here, little square. So we know it's talking about a right angle, so we know it measures 90 degrees. Now our 90 degrees has been chopped into 2 pieces, and we know we've got 63 degrees one side, and we need to work out this one. So we use the knowledge that we need 90 degrees altogether, and we've got 63 of those already. So our missing angle is 90 degrees, subtract the 63 degrees we already have. Our missing angle is 27 degrees. Another angle property, opposite angles around a point are equal. Now the important thing is you look for this shape where the line goes all the way through and out the other side, and the other line goes all the way through and out the other side too. Okay, this is a shape you need to look for this property. Now, note the angles marked A both measure the same as each other, as do the angles both marked B measure the same as each other. Note how angle A and B together form a straight line, so they form 180 degrees between them. Okay, so let's try some calculations. We've got find the angles marked A, B and C. Now usually it's easiest to do this in alphabetical order. So let's start with A. Now I can see that A is opposite the angle marked 29 degrees. Therefore A must be 29 degrees also. Now let's look at angle B. I can see the angle B along with the angle of 29 degrees that I've just worked out form a straight line. They form a half turn there. Indeed, I could look at angle B with this 29 degrees and see that the two of them together form a half turn. Okay, so let's just work this side now. So angle B plus this 29 degrees are going to make 180 degrees in a half turn. So angle B therefore needs to be the missing part of that 180 degrees. So angle B is 180 degrees that I need. Subtract the 29 I already have. Angle B is 151 degrees. And lastly, angle C. Well, angle C is opposite the angle of 151 degrees we just found. So angle C is 151 degrees also. Another property. The angles in a triangle add up to 180 degrees. Calculate angle E. Okay, there are 3 angles in a triangle, and between them they make the 180 degrees. Now I've got 49 here, and I've got this little box in this corner. We know this little square here means this is a right angle and it measures 90 degrees. So I have an angle of 49 degrees and an angle of 90 degrees. And I need to see what E would measure. So I need a total of 180. So E must be the total of 180 that I need, subtract the 2 angles I already have. So my 90 and my 49 degrees add up to 139 degrees. So E is 180, subtract the 139 degrees I already have accounted for in these 2 corners. So E is 41 degrees. Okay, the angles in a triangle add up to 180 degrees. Now we've got a different type of triangle here, and it's got these funny little dashes on there. Now those dashes denote sides of equal length. So all 3 of those sides are of equal length. Therefore, it's an equilateral triangle. Now the other property of an equilateral triangle is that all 3 angles are equal also. So if I need 180 degrees in a whole triangle, and I've got 3 equal angles, each angle must be 180 degrees divided by 3. So each angle is 60 degrees. Now we have a different type of triangle here. I've only got dashes on 2 sides this time. So these 2 sides are equal and this one isn't equal. So this means this is an isosceles triangle. Now the base angles of an isosceles triangle are equal. And what we mean by the base angle is where the equal sides meet the non-equal side. So here's one of the equal sides. We go down and find where it meets the non-equal side. And this angle here is equal with down here where the equal side meets the non-equal side. It's equal to this angle here. So these base angles are equal. Now if the triangle was upside down, these base angles might be at the top, but it's where we meet the non-equal and the equal side to meet each other. Okay, so we've got 25 degrees up at my non-equal angle, and I need 180 degrees altogether. So if I've got 180 and I subtract the 25 degrees that are already accounted for, I need another 155 degrees in that triangle. And as my 2 base angles are equal, that 155 degrees needs dividing equally between those 2 angles. So 155 divided by 2 is 77.5. So each of those angles measures 77.5 degrees.